Hello everyone, this is Lema Aaron, a second year student of Makerere University, pursuing Bachelor's of Science in Software Engineering. I'm to present one of the project of artificial intelligence. Let me first share the screen so that we can move together. Let me share the screen. Yes, sir. The screen. Like I said, I'm coming to present one of the projects for artificial intelligence, in which the plagiarism detector is the one I chose. To introduce it briefly, plagiarism is just an act of taking someone else's work. It is very rampant on the internet and in the classroom. Authors writing blog posts may want to check if someone has stolen their work and posted it somewhere. To avoid that, we need to design a software check that such as, the next slide is just the software I chose to design. That is the plagiarism detector corpus. Below, just some briefly how it is going to work. The corpus will be able to integrate plagiarism detector schemes by utilizing both the figures and their related text, both inside and outside the figure. The corpus will also help out the research community to detect the plagiarism in the figure copied from different sources illegally. This will help the researcher to remain the sole proprietary of their contribution. The next slide is about the factors I considered before selecting the dataset for the project. That is the plagiarism detector. One is the domain expertise. The garbage in and garbage out philosophy was extremely valid for training dataset for machine learning. The machine learning algorithm will learn whatever data you feed it. So if you feed a machine learning algorithm with low quality data, you'll be expecting low quality algorithm work from the machine. The next factor is the right quantity. They need to assess and have an answer ready for these basic questions around the quantity of data. The size of sample needed to yield expected performance outcome. Continuing with the factors I considered in choosing the dataset, the past history. Many scientists have already worked on problems in the past and come up with the training data sets for their specific modeling needs. Working on applied machine learning problems makes it easier to not obtain the right set of data, but also there is a certainty to the result anticipated. The last factor I considered is aggregation. Aggregation compounds multiple variables featuring similar attributes into a single bigger entity. For some machine learning dataset, this may be a more sensible way to build the dataset for solving the problem. So these are some of the factors I considered in choosing the dataset for my project. These are the features the project will use in solving the problem. One of the features is the shape-based features. which I'm going to share the link. Then the textual reference-based features is another feature I also consider, and then the hybrid of set-based and textual reference-based. Yeah, I'm going to share the link for the features, the project we use. And then the next slide, we're going to talk about the Bayesian theorem. Now, in probability, the Bayesian theorem, in probability and statistics, Bayes theorem, named after Thomas Bayes, discovered in 1762, described the probability of an event based on prior knowledge of conditions that might be related to the event. Below is the formula for Bayesian theorem. Probability of A stroke B, in other words, probability of A given B. The probability of event A occurring given event B has occurred, where P of A is the probability of A and P of B is the probability of B. So the formula of Bayesian theory therefore becomes probability of A given B is equals to probability of B given A times probability of A divided by probability of B. We continue here with the Bayesian theorem. The Bayesian theorem lets you calculate the posterior or upgraded probability. This is a conditional probability. Yes, it is a probability of hypothesis being true if the evidence is present. It does not only apply in mathematics, but also real-life machine learning applications, such as in internal marketing to profile visitors to a website, also in decision analysis and decision trees. That is a brief description of the Bayesian theorem in machine learning. The next slide will discuss about the naive Bayes. Naive Bayes classifier are a family of simple probabilistic classifier based on applying Bayes theorem, which means the naive Bayes is applying Bayes theorem with strong independence assumption between the features. It's a classified algorithm that is suitable for binary and multi-class classification. It performs well in cases of categorical input variables compared to numerical variables. It is useful for making predictions and forecasting data based on historical results. Now in naive Bayes, this is how data is prepared, how the naive Bayes prepares data. The first step, it calculates the prior probability for given class labels. Then the next step, it defines the likelihood probability with each attribute for class. Then the third step is puts this value in Bayes formula and calculates the posterior probability. Then lastly, it sees which class has higher probability given the input belongs to the higher probability class. Naive Bayes is a supervised learning algorithm for classification, so that the task is to find a class of observation, in other words, the data point given the values of features. So here's the formula. Probability of C given X equals to the probability of X given C times probability of C divided by probability of X, where probability of C given X is the posterior probability, the probability of X given C is the likelihood, and the probability of C is the class prior probability, and the probability of X is the predictor probability. That is the brief description of naive Bayes in machine learning. And then the next slide, we're going to talk about the Bayesian networks. Bayesian network is a probabilistic graphical model that represents a set of variables and their conditional dependencies via a directed acyclic graph. They are used to build models from and or expert opinion. They can be used for a wide range of tasks in machine learning, including predictions, anomaly detection, diagnostics, automated insight, reasoning, time series prediction, and decision making under uncertainty. Continuing with the Bayesian networks, it consists of two parts: a quantitative component in the form of directed acyclic graph, that is the DAG, the DAG. The other part is the quantitative component in the form of conditional probability. That is brief about the Bayesian networks. The next slide gives the differences between the Bayesian theorem and the naive Bayes. The naive Bayes assumes conditional independencies, where the Bayesian theorem does not. That is just a clear difference between them. This means the relationship between all inputs features are independent. Maybe not a great assumption, but this is why algorithm is called naive. That is the difference between the Bayesian theorem and the naive Bayes. Then the next slide also describes or gives the difference between the naive Bayes and the Bayesian networks, which I forgot to write the difference between, but excuse me for that. The Bayesian network, in the Bayesian networks, models relationship between features in a very general way. If you know the relationship or have enough data to derive them, it's appropriate to use the Bayesian networks. Meanwhile, in the naive Bayes, just a simple model that describes a particular class of Bayesian network, which means the naive Bayes will be describing the Bayesian networks where all of the features are class conditional independent. Because of this, there are certain problems naive Bayes cannot solve. However, its simplicity also makes it easier to apply, and it requires less data to get a good result in many cases. The next difference is that the Bayesian network is more complicated, meanwhile the naive Bayes is less complicated compared to the Bayesian network. Then the last difference is Bayesian network. In Bayesian network, the features are selected based on some scoring functions and a minimal description length. Meanwhile, in naive Bayes, it's a restricted form of a general Bayesian network where you enforce the constraint that the class node should have no parents and that the nodes corresponding to the attribute variable should have no edges between them. These are some of the differences between the naive Bayes and the Bayesian networks in machine learning. The last slide is just the references where some of the work I got some of the work I used in the presentation. Thanks for your time. Yeah, I really appreciate it. You may choose to subscribe if the work caught your eyes, or if you, since I'm still learning. As I said, I'm a second-year student of Makerere University in software engineering. This means I'm still in the process of still learning. If you choose to support me, you would also choose to subscribe. Thank you. Thank you for your time.